All right, guys, happy Tuesday. Coming back from break. I hope you did okay with the first lesson. I'm going to post the answers this morning, but we're going to look at now transitioning to the coordinate plane. So the coordinate plane is dealing with your x and y axes, and we're going to start putting points on that coordinate plane. Today you don't need graph paper. Tomorrow, if you have graph paper, beginning tomorrow, you should start using that. If you don't, you can make your own grids, but it would be easier if you use graph paper tomorrow. Okay, so what I want us to do as we start off this lesson is we're actually going to start off drawing a coordinate plane, and we're going to make it a 4x4 each direction. Excuse me. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So what we're going to be doing today is we're going to be looking at the vertices of polygons, and then from those vertices, can we determine how far they are from each other, and therefore get into perimeter and area, which is where we're still camping on with polygons and finding perimeters and areas, which is also review of what you've done before. So go ahead and put points on -2, 2, -2, 2, 3, 2. So I'll put those up here. -2, 2, -3, 2. Oh, excuse me, not -3, 2. Just +3, 2. And then -2, -1. And 3, -1. Which, that one I'll put over here. 3, -1. So I hope you can see those. I know the glare is pretty bad, but -2, 2, 3, 2, -2, -1, and 3, -1. All right, so go ahead and put points there. I'll give you a little bit of time to do that. -2, 2. And I'll label those -2, 2 up here as well, so you can check yourself to see how you did. I'll just go 3, 1, 2, 3, -1. And then 3, 2, 1, 2, 3, 1, 2. And then -2, -1. Okay, so I have those coordinates, and I put those points where they belong. Now, did you notice here, if I connect these 4 dots, I would have what kind of figure? Well, it'd be a rectangle. So I'm going to go ahead and do that. So I have here a rectangle, okay? Now I'm gonna find the perimeter and the area of this rectangle, and this one's a nice easy figure. You'll mainly be dealing with triangles, so we'll have to get ready for that. But here, let's find the distance between, or let's find the length, which is the distance between this point and that point, or these 2 points. Okay, so we'll look up top. And a lot of you, what you want to do is, what you're going to want to do is like just skip count, right? 1, 2, 3, 4, 5. So this length is 5, and I'll put that up there, 5 units long. Therefore, this must be 5 units long. Okay, that's one way of doing it, but in your homework, they're not going to give you the figure, and they're not going to ask you to put it on a coordinate plane yet. You're going to actually do that more tomorrow. So how in the world am I supposed to find the distance between these 2 points if I can't even draw them out? Like, is there another way to do it? Okay, look at these 2 points. So -2, 2, and 3, 2, which are up here as well, right? These 2 points. How do I find that difference? How do I find that distance between these 2? Well, I have to use the difference. Okay, do you guys notice that the y coordinates are the exact same thing, and the x coordinates are different? Okay, so look at the y coordinates are exact same thing. The reason they're exact same thing is because on that y-axis, they're in the same spot, right? They're in the same spot. Like, if this is your y-axis, that vertical axis, these 2 guys are in the same spot. So I don't use the y-axis to find the distance between these 2 points. I'm going to use the x-axis. Now look at the 2 coordinates for the x-axis, -2 and 3. All right, how in the world can I get 5 from that? What I do is I take those 2 coordinates, -2 and +3, and I subtract those. Okay? So what's negative 2 minus 3? What's negative 2 minus 3? It's negative 5, right? The distance between these 2 points is negative 5. But some of you, hopefully are thinking, wait. Can you have a distance that's negative? And the answer to that is no. But what if I took the absolute value of negative 5? So going back to the recesses of our memory, what does absolute value mean? It's the distance of a number from 0. So what's the absolute value of negative 5? Positive 5, right? So negative 2 minus 3 is going to be negative 5, but the absolute value is positive 5. And that's how you can get the distance without even putting the points on a graph. Okay, so that's that distance, but you know what? I'm not really a fan of that. You know, maybe you're thinking to yourself, let's look at these two ordered pairs right here. Do you notice that they have the same y-axis, or same y-coordinate, right? Negative 1. But look, a different x-axis coordinate, negative 2 and 3. What's negative 2 minus 3? Well, that's going to get me, again, negative 5. What's the absolute value of that? Positive 5. So the distance between these 2 points is positive 5. Okay, if I have two coordinate pairs that have the same y value, then I subtract their x coordinates, right? And that'll get me 5 or 5 up here. Now let's see if we can apply it here with these 2 points, negative 2, 2, and negative 2, negative 1. All right, notice, what do those two have in common? The x coordinate, right? You see how they both have negative 2 in the x coordinate spot? Okay, so I'm not going to use those to find the distance. I'm going to use the 2 and the negative 1, the y coordinates. So I reversed it because now I'm talking about this horizontal plane here, or this vertical distance. So I'm going to do 2 minus negative 1. 2 minus negative 1. So what does that come out to be? 2 minus negative 1 is the same thing as 2 plus positive 1. So what does that get me? 3. And if I did my skip counting, I'd get 1, 2, 3. So it also works if I put it in the coordinate plane. Okay, that should also work with these 2 points right here, right, to find that same distance. And you got to be careful because here people just do, what's 2 minus 1? Well, that would obviously be 1, but that's not the answer. So what's 2 minus negative 1? Well, it's 2 plus 1, which also gets me 3. Okay, so I have all the numbers, and I had here 5. I have all the numbers that I need. What's the perimeter of this figure? Well, 3 plus 5 plus 3 plus 5. Or you can think of it 10 plus 6. That's 16. So your perimeter is going to be 16. And then you also have to find the area. And here I'll have you put in units. So 16 units around the shape, the perimeter. And then the area of this rectangle is the base times the height. So it's 5 times 3. It's going to give you your 15 square units. If you notice on your quiz, some of you were missing points, like 1 point on some problems. Some of your units were either missing or wrong. If I'm talking about perimeter, I just have units. And if I'm talking about area, it's square units. So make sure you put those in on homework, and then you'll get used to doing that for your test. So that's what I have here for this figure, and that's if I drew it all out. But what happens if I don't draw it out? Can I still find the perimeter and the area? Okay, let me give you an example here. Negative 3, 2. So here are 3 points. Negative 3, 2. And then we get 2, 2. And then 2, 0. Okay, so the way you're going to have to find this perimeter and area is realize, okay, I have 3 vertices. So what shape am I dealing with? It's a triangle. Okay, and find the perimeter of a triangle and find the area of the triangle. We're going to look at after we find some things. But if these are the vertices, I need to know the side lengths. And one thing I'll recommend here, because you won't have a ton of problems on this, but you'll have a few, is maybe sketch out. You don't have to make it perfect, but I just draw a little coordinate plane, and then I put these approximately where they go. So negative 3, 2, And I'm not even drawing the tick marks, right? 2, 2, 2, 2, 0. So see those points right there? And that's going to give me my triangle. Okay, so that's negative 3, 2, that's 2, 2, and that's 2, 0. And if you need to redraw that up for yourself, that's fine. And again, you don't have to actually put the tick marks. You're just kind of sketching it out so you can see, get a visual of where these points go and what you're looking for. All right, how in the world am I going to find the distance between these 2 points? So the negative 3, 2 and the 2, 2. Okay, remember, they both have what in common? The y-coordinate. So that's going to be common because they're both on the same spot on the y-axis. So I'm really looking at the x-coordinates. So what's negative 3 minus 2? So what's negative 3 minus 2? That's going to give me negative 5, but you can't have a distance that's negative 5, so you have to find the absolute value of that. So it's almost like doing that. So you get a 5 again. So we got that number 5, the distance between these 2 points. What's the distance between these 2 points right here? Well, notice that their x-coordinates are exactly the same. So here I have 2, 2 in the x-coordinate, and then 2 and 0. So I'm going to find what's 2 minus 0, absolute value. And what's 2 minus 0? 2. Absolute value of 2 is thankfully just 2. So that's going to be a 2 right there. Okay. So I can already find the area of this triangle by multiplying a base times a height, or base times a height. Notice this is a right angle right here. So I can find the area because the area of a triangle is going to be 1/2 base times height. So I'll go ahead and do that. The base, again, if this triangle was flipped on its side or upside down, you could get a base. So I'm just going to say the base is 2 and the height is 5. 1/2 times 2 is 1. 1 times 5 is 5. And if we're talking about area, square units. So that would be your area. Okay. And I'm going to do this on these. I want you to find the area because I'm thinking the perimeter. Like I'd have to find the distance between these 2 points. And that's using the Pythagorean theorem, which if I'm trying to recall, I don't think we've used it. And if we have, we'll just skip that for now. We'll go over it tomorrow. But we're going to find the area of these triangles, definitely. Okay, let's get one more example if I have time. Yeah, I have time for one more. Again, you're going to do mostly with triangles, so that's why we want to get these down. So make sure to find the area. We'll wait on the perimeter. Okay, they're going to give us -2, -2, 5, -2, 10, and 10, 5. Okay, and if I'm just sketching out a little diagram, -2, 5, -2, 10, and 10, 5. Okay, so that's why triangle, but honestly, you don't even need that. You really don't need to do the diagram. This is just for those who need to have a visual. This is what you really have to do. Okay, you have to look at these 3 vertices and find out what's the distance between each type of pair, each pair. So I'm going to find the distance between these 2, and between those 2. That's how you find the perimeter. But this will help you to know which ones to find to get that area. So here I had -2, 5, and then up here I had -2, 10, and then over here I had 10, 5. Okay, that helps me out. Okay, I want to find the distance between these 2 points right here. All right, so I'm going to do which coordinate is the same? Is it the x-coordinate or the y-coordinate that's the exact same? Well, it's the x-coordinate, -2, -2. So I'm going to leave those alone and deal with the y-coordinates. What is 10 minus 5 absolute value? That's 5. So this distance right here is 5. I'm going to circle that so I know what I'm talking about. Okay, between these 2 points, negative 2, 5, and 10, 5, what's the distance between these two? Well, what do they have exactly the same? 5, okay? So we're going to leave that alone. So we're going to deal with negative 2 and 10. So what's negative 2 minus 10 absolute value? So what's negative 2 minus 10? Negative 12. What's the absolute value of negative 12? 12. So this distance would have been 12. And that's all I need to find the area. So I'm going to do 5 times, I'll put the formula here. 1/2, base is 12, height is 5. And I would recommend continue to write the formula and just fill in the spots because, again, on that quiz, some of you were just doing the work and you were miss a step or add a step or change a step. But here it tells me exactly what I need to do to solve for the area. So what's 1/2 times 12? 6. 6 times 5? 30 square units. Okay, so on these problems that say to find the perimeter and the area, just find the area. And then you'll get problems where they just give you 2 coordinates. So they'll give you these two, and they'll say find the distance between these 2 coordinates. And all you have to do is say, all right, what's the same? Keep that the same. What's the ones that are different? 5 minus 10. And you find the difference between those 2 points. So you'll do that the first section. And in the second section, you'll find the area of triangles. And that will be your homework for tonight, which I'll write it down now for you guys. And don't forget, if you can get graph paper tomorrow, we're going to need it because we're going to start doing some translations, reflections. So your homework for today is going to be 2 through 14, even. And that's going to start on page 313. 313. So go ahead and do those problems. If you have questions, we'll have a Zoom session. I believe it's at 1 o'clock today, but I'll write that in the description for the video. Okay, see you guys. Take care. Bye.